Okay, so we have a bunch of different ways to list elements of a set, right? So if we were talking about something like marbles and we wanted to say how many marbles do we have, we could actually for real list that out. We could say, okay, I could have one marble, or I could have two marbles, or I could have three marbles, and maybe I could have infinitely many marbles. This is called roster notation. And the reason I can list these out is even though there's infinitely many, there's kind of an order to it. Like if I say one, two, three, like it, you can tell that it's four, five, six, and so on all the way forever. But if we wanted to list all of the real numbers in between one, two, three, etc., we couldn't actually do this because the real numbers have irrational numbers in them. Like, sure, there's regular numbers that we're used to, like 1, 2, and 3, and 1.5, and 1 3/4, and 2.5, and 2.1. But there's also like infinitely many decimals in there, and there's so many that there's no way that I could actually list them. So I can't use something like roster notation if I want to say, hey, all the numbers ever between, say, 4 and 6. Okay, so let's write that down. All the numbers between 4 and 6. Now, a lot of people will think, oh, well, that's 5. But remember, there's 4.5 and 4 3/4. And no matter what numbers you give me, I can always find more numbers to have included in this list. So we can use what's called the set builder notation, where you're saying, hey, guys, we can use any number x as long as x falls in between 4 and 6. So the way we would write that is the set of all x such that. Now that bar means it's read out loud as such that. But what it means is, hey, I'm going to list all the properties of the numbers that x is allowed to be. And so if I want x to be between 4 and 6, x has to be both bigger than 4 and less than 6. So this is called set builder notation. Now, if I did this on a number line, I could color the number line. So somebody who maybe couldn't read the set builder notation, maybe they could read the coloring. So let's look here on a number line. Here's 4, 5, 6. And of course, the numbers on the number line go in both directions. That's why there's arrows here. But I'm just going to focus on 4, 5, 6. And I'm going to say, oh, well, they have to be somewhere in here. Now, you'll notice in this example that I said that they're strictly between 4 and 6. So I need some sort of notation on this number line that says, hey, reader, not equal to 4, not equal to 6, strictly between. So the symbol for not equal to, like you can see it in blue here, it's x is bigger than 4, not bigger than or equal to. So on my number line, I have to account for that by using either open circles, or I can use parentheses, and that's what I'm going to use here. So let me erase my circles, and I'm going to use parentheses. So let's note that the parentheses mean not allowed to be equal. To this value. So x can be equal to any number in between 4 and 6, but it cannot be equal to 4 and it cannot be equal to 6. Now, what if I changed my problem, right? So this will be problem number 1. Let's do problem number 2. I want to tell my reader, hey, all the numbers between 4 and 6, but now I also want 4 and 6 to be allowed, right? So, or equal to 4 or 6. So here, you notice it's so many words. This is why we have all these symbol notations, like to make it a shortcut for writing. So let's do that in the set builder notation. The set of all x such that, and now I still need x to be somewhere between 4 and 6. But now, since it could be equal, right? Equal to 4 or 6 is also an option. So I'm going to put this yellow or equals to make my notation x is greater than or equal to 4 and x is less than or equal to 6. Now, on a number line, the picture would look very similar to the last picture, 5, 6. I would still be considering these numbers in between 4 and 6, so many that I have to draw this picture. But now I need to tell my reader, hey guys, we could actually be equal to 4 or we could be equal to 6. So there's one notation that would be a closed circle, which of course it like disappeared. Oh, one note. Okay. So the closed circle notation tells the reader, hey, or equal to. But a better notation, I'm telling you about the dot notation because you might see it if you Google, or watch a YouTube video. So I'm going to take my circle notations off here, and instead I'm going to use a bracket notation. So I'm going to use a square bracket on 4 and a square bracket on 6. So that tells me, hey, anything in between 4 and 6, but you could also be equal to 4 or you could also be equal to 6. So the square bracket means allowed to be equal to this value, allowed to be equal to this value. Now, you could have an even smaller, shorter symbolic notation, which is called interval notation. And interval notation is actually the preferred notation of mathematicians across the globe. So the interval notation takes the number line notation with the parentheses or the squares, and it just writes the numbers. So on number 1 here, I could have, for interval notation, I could have all the numbers from 4 to 6. So I'm listing the edges only, and I'm listing them in numerical order leftist to rightist. And then I would wrap these up. Since there's a parentheses here, I would put a parentheses on 4 and then a parentheses on 6 as well, because I wasn't allowed to be equal to. Now, that looks an awful lot like a coordinate, so you're going to know that it's an interval based on the context from the question. Now, in the second question, where I have or equal to 4 and or equal to 6, for my interval notation, I'm still going to do leftist to rightist, but now I need to tell my reader, hey, you're allowed to include 4 and you're allowed to include 6. So I would put square brackets on those. Now, the edges don't have to match. So you could have one of them you're allowed to be equal to and one of them you're not allowed to be equal to. So let's finish up just with these same numbers, 4 and 6. Let's do all the numbers between 4 and 6 or equal to 4, but not equal to 6. Again, see how many words that is? You want to have symbols so you don't have to write so much. So in this set notation, I would have the set of all x such that I would still have my x in the middle, and it would still be between 4 and 6. But now, since I can be equal to 4, this symbol has to get the bar underneath for or equal to. But now the other symbol on 6, not equal to 6, is going to keep this same symbol, just strictly less than. Now, on a number line, I still only really care about 4 to 6. I'm only listing 5 so you can see the order, but I literally normally would just list just the 2 numbers I care about in the proper order left to right. And I'm still going to highlight in between those guys, right? So in between 4 and 6. But now I need to tell my reader, hey, you're allowed to be equal to 4, but you're not allowed to be equal to 6. So I'm going to put the allowed to be equal to notation on my number line, which is a square bracket. Oh, one note. All right. And then on 6, I'm not allowed to be equal to, so I'm going to use a parentheses. So the interval notation in this situation, interval, I'm still going leftist to rightist, 4 to 6, but now 4 I'm allowed to be equal to, so it gets a square bracket, and 6 I'm not allowed to be equal to, so it gets a round bracket or a parentheses. All right, I hope that helps.